So you might have to do a lot of pausing for this, guys. Welcome, welcome. Day 4 of probability. So there's only 4 days. We want to review these concepts because you never know when you'll see them, especially on ACT and SAT. So day 4, define and use probability. Again, you're definitely going to want to pause and write down these definitions. So probability, the likelihood of an event occurring, it goes from 0 to 1. Because the 0, when will this not occur? When will this never occur? Compared to when is the event going to occur? So 100% chance that you are watching this video right now, okay? Compared to a half. So flipping a coin is an example of the probability of landing on heads. Theoretical, this is what could happen, okay? So the ratio of favorable over total. Theoretical probability, again, here's the definition. So what is the number of favorable outcomes compared to the total? The total goes on the bottom, okay? So how many different outcomes could there be? So what could happen? Let's do this for a dice, okay? So a dice is rolled. What's the probability of landing on the number 5? Well, there are 6 sides to a dice, and only one of them is the number 5. Compared to what is the probability of getting even? Well, that's 3 out of 6. Which reduces to 1/2, okay? And then the next one, if a number is randomly chosen from 1 to 20, what's the probability of getting a perfect square? Okay, so perfect square, right? That's square root. So let's think of the numbers from 1 to 20. So we've got 1, 4, 9, and 16. So that's 4 out of 20 pieces of paper, which reduces to 1/5, okay? And then what is the probability of the numbers 1 through 20 getting a factor of 30? So numbers that go into 30. So what goes into 30? 1, 2, 3, not 4, 5, 6, not 7, not 8, not 9, 10, 11, 12, 13, 14, 15. There we go. So 1, 2, 3, 4, 5, 6, 7. 7 out of 20, and we don't have to reduce that. So again, this is what could happen. This isn't what actually happened. All right, does order matter? So we're reviewing a little bit about combinations and permutations. So combination, order does not matter. So if I'm picking out 3 pairs of socks out of 10 pairs of socks to go on a trip, the order doesn't matter of how I'm picking the socks. Compared to permutation, order does matter. It matters when I have a locker combination, or how am I going to open my phone, okay? So it matters how I put in those numbers, what the order is. Austin has decided to participate in a talent show. There are 7 musicians. Okay, and what is the probability that they're chosen in alphabetical order by their last name? So in this one, order does matter. Going first compared to going last in a talent show. So we're talking permutations. So 7P7, okay? There are a total of 7, and we're asking the order of 7. So I'm going to get out my calculator. I'm going to type in the number 7. I'm going to go to math, scroll over to probability, PRB. I'm going to scroll down to NPR, and then I'm going to type in 7 again. So 7P7, 7, NPR 7. And my answer is 5,040 different ones. Okay? So those are the different ones that we can solve. All right, awesome. So what if they asked, when could Austin, or like, what if Austin was the first 2 spots, right? If they said something like that, right? What is the likelihood, or what is the probability of him being the first 2 spots? Then you would do 7P2. Okay, so the second number is how many. The first number is the total, and then the second one is what are you asking for, okay? I wanted an example of a combination question, so I changed the second one. If you want to just cross that out and just kind of make a note to this information, I found this question from the ACT kind of website, and I thought it was a great question to kind of talk about, okay? Because sometimes with these word problems, they don't want you to actually solve it. They just want you to set it up, okay? So a group of students are selected to be on a council at Reno High. There are 18 juniors and 12 seniors. So find the number of ways the council can be chosen if they select 5 juniors and 5 seniors. So again, this one, it does not matter what order. There are 5 juniors and 5 seniors. There's not a ranking of like, these are the first ones chosen. That's not how they do things, okay? So 18 juniors. So 18 C5, because there's 5 being picked, times 12 C5, because these are the seniors. So the juniors and the seniors, and then you'd multiply these together, okay? So then you can come over to this lovely calculator business and do 18 probability, and then go down to NCR 5, okay? And then I have 12 probability, so math probability, go down to NCR and 5, and then multiply those together. So 8568 times 792. And you'd get 678, 58, 56. So write that down for that number, for that problem. So there's that many combinations. All right, moving right along. All right, odds be ever in your favor. So if you ever watched Hunger Games, that's what they're talking about, is the odds. So the odds are something that can occur compared to the times it cannot occur. So you go into the Hunger Games or you don't go into the Hunger Games. There is no total, okay? Odds in favor are when they are equally likely to occur, okay? So they're all equally likely to occur in this situation. So odds in favor of an event means when does it happen and when does it not happen. If you hear the phrase odds against, that means when it doesn't happen compared to when it does happen. So it's the reciprocal of each other. So be very aware of when someone says in favor of compared to when they say odds against. All right, so make sure you're writing this down, pausing, all the good things. Thank you for those who are listening. I really appreciate it. Hopefully it helps. So odds can be written as a fraction or as a ratio. They can be written in 2 different ways. And again, make sure you can simplify also. So simplify those ratios. All right, let's do some examples. A card is drawn from a standard 52 card deck. Find the odds of drawing a 10. So the odds of drawing a 10. So we want the probability of landing on a 10 over the probability of not getting a 10, not landing, right? Choosing, drawing, hello, cards. So how many 10s are in a deck? There are 4. How many are not 10s? That's 48. I did 52 minus 4 to get 48. Now let's reduce. So I can take out a 4 on top and bottom, and I get 1 over 12. Okay? I can also write it 1 colon 12. Okay, again, odds 4. This means odds against drawing a club. So I want the probability of not getting a club. Let's see if I can draw a little club. Okay, and then the probability of getting a club. Okay, well, there are 4 suits in the deck. 13 of them are clubs. And then you have to do 52 divided by 13 to get how many are not, which is 39. And then can I take a 3 out? No, so I just leave it as is. Okay, again, you can also write it 39 colon 13. Odds against, so please be careful on the order of how you're writing things. It matters. Okay, a marble is drawn from 6 blue, 6 yellow, 9 white, and 11 green. Find the odds in favor of drawing a yellow, mellow yellow. So we need 6. So 6 is how many that are yellow and how many are not yellow. So 6 plus 9 plus 11. And that is 26. So probability of landing on yellow and the probability of not choosing yellow. I don't know why I keep saying landing. All right, choosing. So 3 over 13. Okay, or 3 colon 13 because it said odds in favor. All right, moving right along to experimental. What actually happened, y'all? What actually happened? So repeating an experiment and recording the results. How many times did you do it? How many compared to how many times it actually happened? Okay, so what actually happened? So here's a test score. What's the probability of someone getting a C or better? So C or better. Okay. All right, so I need to count how many I got. So there are 27 people that got a C or better. Okay, so that is these 3. Boop, ba-doop, ba-doop. compared to how many are there total? So 27, 28, 29, 30, 31. So 27 out of 31 people got a C or better, which is great. That's a great average. Can I reduce that? Nope. Moving on. All right, one more. So how many people would like to prefer to be 40 years or older? Okay, so greater than or equal to 40. So I have to look at these numbers. You want to add those up, okay, out of the total. And then you have to find the total of all of these put together. So solve those and check back. All right, so I added these three together. So 40 and above, at least 40 years old or above. So that's the ages compared to the total number. And then you'd want to reduce that fraction. Okay, so when are we dealing with totals compared to when are we dealing with odds? So the difference between them. Okay, all right, the last type is geometric probability. So pause and write this information down. So this is geometric probability. So one-dimensional, two-dimensional, and three-dimensional. So if you are trying to do one-dimensional, what is the length over the total? So you just want to write the different types. So the one on the bottom is going to be about area because it's about a dart. Hitting a dart, hitting a target. So that's a two-dimensional situation. So what is the probability of landing on 10? So we need to find the area of the smallest circle. So that radius is 3. And then we need to find the area of the entire dart area because it says total area on the top. So the area of the small circle over the area of the square, okay, because you can hit the outside of that also. Okay, so find out what that is. So pi times 3 squared. And then 18 times 18. That's 324. And if it was a decimal, then you could go further and figure out 9 pi and then divide that by 324. You get 0.087. So there's like a 9% chance of hitting the target in the 10-point area. Okay, now let's figure out what the probability is of getting 0 points, so getting into that outside of the target. So we want to figure out what is that area of just the 0. So we're going to find the area of the whole thing and minus it by the biggest circle, the blue circle, and then go from there. So we already figured out that the area of the square is 324. And then the area of the biggest circle is pi times 9 squared because it's 3 times 3 times 3, or sorry, 3 plus 3 plus 3, and the radius is 9. So then you have 81 pi minus 324, and then we can figure out 81 times 3.14, so 254.34, and subtract that by 324. That's 69.66 over, and then what is the probability again of the entire thing? So it's asking you what's the probability of getting just this little section right here over the total area of the whole dart area. Okay, so 69.66 divided by 324. And that likelihood is actually more than getting 10 points. So that is 0.215, which is roughly 0.22. All right? All right, thanks.